to Aerotech's Automation1 Motion Control Platform educational series. Aerotech is a company that solves your toughest precision motion and automation challenges. Automation1 is a motion control platform consisting of software-based controls and development tools, PC and drive-based control hardware, and hardware-based drives for servo motors and other devices. In this video, we will take a guided tour of the Automation1 Visualize workspace and take a brief look at the workspace layout, configuring signals, 1D and 2D views, triggering data collection from AeroScript. My name is Chris Charlesworth, and I am the European Control Systems Engineer for Aerotech. Let's begin by taking a look at the workspace layout. In the top left-hand corner of the Automation1 Studio screen, we have our different workspaces, and you can see the Visualize workspace is the fourth icon along, after the Configure and Develop workspaces. When you go into the Visualize workspace, it is fundamentally going to be a oscilloscope type interface. So if you've already plotted something, you'll have the time running across the bottom, and then you'll have various different signals displayed. So we're going to take a little bit of a tour around this. We'll start with the top left, where we have the button for configuring signals. We'll go into more detail on that in a moment. You have different triggering options. You can just collect a single snapshot. You can collect repeated snapshots if you want to, and you can also do collect continuous. Collect continuous is very useful if you want to have live feedback while the system is running. So I've used it before for debugging a system. I've plotted out the encoder feedback while trying to fine-tune an alignment problem. And I've also used it during a trade show to have a constant view of what the machine is doing on the screen. So it's pretty cool, and you can do some quite cool things. We've then got a stop collection button and a stop collection after completion. The stop collection button will stop any collection in progress immediately, and the stop after completion will stop a collection after it's finished its snapshot. So the collect repeated snapshots just keeps taking snapshots one after the other. So if you were partway through running one of those, the stop after completion button would stop it once it finished that collection cycle. There's an open file button, so it's the little folder type icon, that allows us to open up plots that are already saved or data files that we've collected in other ways. We have more information on that in some other videos. We also have the save button, so this allows you to save out the plot file for later viewing. Really does come in handy if you want to go, oh, I want to show this to somebody later. On the right hand side, we have mostly the different display options that are available. You can swap to the 1D view, the 2D view, a 1D 2D split view, which we'll show a little bit later. There's a fast Fourier transform view if you've been running fast Fourier transforms, and there's an overlap plot view. Now, if you haven't overlapped any plots or run an FFT, it will just say this plot does not contain any FFT results. Same with the 2D view as well. We're going to use most of these today, so then you'll see a good example for each. The next one along that looks like a bar chart allows you to turn the zero lines on and off. Can come in handy. Turn on and off grid lines and display data points if you wish. We then look at the signal units and time units. You can choose what sort of signal unit to use, so you can use the primary signal or the count, and you can also define your own unit. You can take the unit type, you can divide it or multiply by a scale factor, so that's very, very useful if you've, say, plotted out in microns and want to see it in millimeters, or millimeters and want to see it in microns. I recently used it on a rotary motor to convert from degrees into radians, so it was very useful for doing that. Again, going back into that section there, we have the time units, so we can do milliseconds, seconds, or minutes. Very useful if you've got a very long process or a very short process. And then we have the overlap options, so we'll demonstrate this in a little while. But this allows you to overlap the different signals. If we take a quick look, you could overlap everything, which is not always the most useful of views straight out, but does have its uses at times. We can overlap by the axis, so you can overlap everything from the same axis. So you can see here the position command and the position feedback have been overlapped at the bottom. And we also have the overlap by signal. You can do a direct comparison between two different axes if you wish. All useful options at the right time. We're going to go to no overlap for now. Next one along, we have the different cursor options. So the first one, the arrow with like a little spark next to it at the point, allows you to place these two cursors. Now, these are very, very useful for understanding your data. If we come down to the bottom left of the screen, we'll close the dashboard for now. There's a cursor data button. Now this can either be at the bottom or at the side. You can open this up and then you can see the data from cursor 1 and cursor 2. I have a demo box attached and set up to the system, so this is real feedback. It's sitting on some floor next to me on a box that's quite unstable, so we can see here that there is some sort of a periodic signal in the x-axis. If we put our cursors at the left and right, we can see the time for those and the difference and what the units are. And we also convert that into another useful unit. For the time, we convert that into hertz, so it can be very useful to understand there's some sort of a 2 hertz oscillation happening. The position feedback you can see here shows you the difference in millimeters and then also shows you the RMS value. So again, quite useful for comparing notes on things. Then you can see we scroll down, it has all the data from the other points as well. That's all very useful. The second one along is a little magnifying glass, and this is the zoom. We can click and drag to zoom into a specific section. So you saw I just clicked and dragged, and I'm going to set it just outside of those cursors and let go. That's just the left click. And then we have the pan function, so this allows you to click and drag along the time scale as you wish. It's worth mentioning that if you wish to, you can use the middle mouse button to do the same thing. So I'm just using the middle mouse here. Quite often I'll do a few different things as I'm working, so the pan is always on the middle mouse. Further along again, we've got the overlap plots function, so you can overlap this plot with another plot. Very useful if you've done a little bit of tuning or you want to see a reaction to something. You can overlap everything and then look at your data. Next one is the FFT, so we'll show this very quickly. Just before we do that, we'll just come down a little and we'll look at the sort of other plot options here. So there's a clear cursors button. There's a reset zoom button, so that just zooms you out to the original plot size. There's also a general plus and minus there, so you can zoom in and just zoom out. I'm going to place a couple of cursors. I'm also going to set my zoom window slightly so that I can show you a few options here. So let's go back to our FFT. I'll click onto it and then we can choose our signal that we want to use, in this case the position feedback. We can choose some different Fourier transform options, so narrowband, PSD and cumulative PSD, what mode, so automatic is normally fine. We've got the windowing, so there's some different windowing modes that you can set, and also the data. We could take all the data from the whole plot. We could take the data just in the zoom window, so you saw I zoomed into this, so that would take everything on the screen, or the data between the cursors. This means that if you've got a much longer plot and you want to see some sort of excitation in a certain area, you can look just at that. We also have the option to remove the DC offset. It makes it a little bit easier to understand what's happening. I'm just going to plot the position feedback, and we can see here it's done an FFT quite quickly. It does take a little bit longer for larger plots, but in this case I'm only sampling at 1000 Hz. Then you can see here we've got a few different peaks, and if I place cursors again, I can also see that cursor data. So I can see there's a peak at 89 Hz, and I can see there's another peak at about 183 Hz in this particular case. You'll notice we jumped to the FFT plot. I can go back to my original plot in here if I wish. If you do more FFTs, there'll be more in this list as well. And then finally at the end we have the settings. Press the 3 dots, opens up the settings for the whole of Studio, but opens directly into the data visualizer for you, making life a little bit easier. Now, a couple of things on here worth mentioning is the show internal signals. A little bit more on that later. I've got it enabled, but we'll disable it for now. I've got a few other bits now. Something very important, how you want to configure your data collection. You can set the number of points, or you can set the length of time. The default for Studio now is the length of time, so then no matter how you change the data collection period or frequency, the length of time will always be the same. It saves you having to do a little bit of math, so you want to do 5 seconds worth of data at 1 kilohertz, that's 5,000 points, but if you increased it to say 10 kilohertz collection speed, you'd then have to do the maths to work out how many extra points to collect. Well, we've made it easy for you, it's always the same length of time. In here as well is the number of unsaved plots. You'll notice back on the main screen, up here where it says plot 1, this denotes how many plots will be in there in the future. You can see I've set this to 30. I do quite a lot of testing and playing around with things, so I've set it a little bit higher, but it will default to 10. You can enable and disable the automatic saving options as well, and also how it timestamps things. Now we'll move on to configuring signals. Next up, let's take a look at configuring signals within the Visualize workspace. In the upper left-hand corner, we have the Configure Signals button. If you look inside the Develop workspace, you will see the same button as the visualizer is also integrated there. It works exactly the same way. Press Configure Signals, and this opens up the Configure Signals dialog screen. There's a few different things to deal with, so we'll start in the top left-hand corner and work our way around. Now, we have two options. We have data collection and plots. Data collection will put inside the configuration settings needed so that when you run a snapshot or the continuous command or any other data collection command, it will define the signals that are going to be captured, also the sampling frequency and sampling time, which is quite important. Let's have a look at the basic setting first. On the far left hand side we have the axis. In this case we're going to plot Vx and Vy. We're then going to select what signals we want to collect. Take a look here, the context for the signals can be system, axis or task based. So we're currently in axis. We're going to collect the position feedback and the velocity feedback. And then we click Add Signals to List. And you can see here, that's just added them straight in. You can see the signal name, you can then see the label, and then you can see the colour they're going to be when they are plotted. Now over on the far right you've also got a couple more symbols, so we have this copy button, so if I wanted to copy the signals from Vx and I wanted to add the same signals for Y, I could just tick Y, press OK, and then the Y has been added, had those signals added. If I want to delete signals, I've got two options. I can delete the individual signal, or I can delete the entire axis worth of signals. As you can see here, I've just restricted this to the Vx, Vy. If I move into the system context, you can see that I've now got a different signal list, and I can capture all of those for the whole system. So that's coming directly from the controller. If I go to task, then I can choose one of the tasks that's being configured, and I can then choose the signal from within that as well. So this comes in handy if we're trying to do more in-depth data capture. It might be something on the task level that's not quite working correctly. One of the things we can look at are things like the coordinated position command. So rather than looking at the as separate axes, we could look at the actual command being given in a coordinated fashion. Top right hand corner, we have the period of sample collection in milliseconds. Now, if we open up the drop down, you can see we've got 1 for 1 millisecond or 1 kilohertz for the sampling frequency, 0.1, so 0.1 milliseconds, which is 10 kilohertz, and we go all the way up to 200. For a standard servo drive, the maximum frequency that you can sample at is 20 kilohertz, as that is the servo rate. For the more specialist drives, so these are the voice coil drives and Galvo drives, they can be collected at 100 or 200 kilohertz, as they have a 100 kilohertz trajectory rate and 200 kilohertz servo rate. We then have the time to collect in milliseconds. In this case, I'm setting up a buffer that's up to 30 seconds. We can change that. We're going to leave it as 30 seconds today, just for simplicity's sake. That is the 1D collection, so that will configure the screen as we've already seen it. We also have the option to configure 2D. In here, we can plot them against each other, so in this case we're going to plot Vx and Vy, and we can then choose one of the items from the list. In this case, we're going to plot the position feedback. We can also choose whether or not we're going to use the same signals for all the axes. And then we'll hit the Add Signals to List, drops them in, and gives us a colour. Again, up in the top, it's still the same settings, so the collection period of 1 and the time to collect 30,000 milliseconds or 30 seconds. There we go. The other option in here, plots. This allows you to configure plots that you've already collected. This can be very, very useful. You can see we've got a couple here. Now, originally, if you saw the screen, you would have seen that I was only collecting the position command and feedback and analog input 0 from the x-axis. You can see they've been set to display. However, we also have some other options, so there are other signals collected automatically, and part of that is because they're actually derived from other signals. So the velocity can be derived from position, and the acceleration can also be derived from position. We also automatically plot things like the current. It's very, very useful. So if I go to plot 1, for instance, at the moment, we don't have any current command data. I want to plot the current command data. It's already there in the background if I press update. And I can now see the current command has been added at the bottom of each set of graphs. Very useful thing to be able to do. You've forgotten to plot something, it's not necessarily game over. Another thing we can do is we didn't plot anything in 2D, but now we can. Let's, in this case, plot the position commands, add the signals to the lists, and press update. And now I'm on plot 1. If I go to 2D, we can now see that they've been plotted against each other for us in this particular case. Another useful thing to be able to do. In this case, though, of course, there was no position command as the axes weren't actually moving. If I come back into there, go to plots, and in this time we will change it to be the position feedback for both axes instead. Sorry, I'm on plot 1. Move over, add the signals, update, and now if we set the window correctly, we will have a small amount of data. You can see it just up here. So if we zoom into that section, you can see there was a subtle movement. It's a very, very small movement because there's no real command there, but you can go back and you can plot these against each other. I'm sure you'll all agree that's a very useful thing to be able to do. And of course, what we can also do here now is plot the 1D and the 2D at the same time. So we've covered how to configure the signals. We've covered the different options available to you. Now the real question is, how do we trigger data collection? It would be very difficult to try and trigger the data collection and then try to run a program. It would get rather messy. Now, of course, we're not leaving you alone here. We're trying to make this as easy as possible. I'm going to go into the Develop Workspace for this. Now, there's a separate video to introduce you to the Develop Workspace in AeroScript, and to go through this in detail, we're just going to focus in a small program I've written already. It's very, very simple. We enable some axes, we home some axes, and then we call a command called app data collection snapshot. That starts the data collection process off and then collects data until we issue a data collection stop command or until the buffer is full. I could just set this running and wait, run a load of programs, and it would only collect 30 seconds worth of data. Or, because this program will only take, say, 3 or 4 seconds to run, what will happen here is it will stop that data collection and display the information for us. We're just going to run this straight away. You can see we've got a message display in the top corner saying that collection started, and then you can see the visualizer at the bottom has updated with the information that we've collected. If we go back to the Visualize tab, that's been opened up, and you can see we drew a diamond, and we can see in the 1D view the position feedback, velocity feedback, for each of the axes. So we can come back into the 1D view. We can see it moved around a little. In the 2D view we have the diamond, and in the 1D 2D crossover view we have the full view. Just before we finish, we will take a look at the internal signal option that we had in the settings at the start of the video. So I've opened up the configure signals option, and you can see in here we have quite a wide variety of different options. You've got lots of things like Galvo laser output raw, the position command feedbacks are up here, acceleration command raw as well. If we go and open up the settings and we show the internal signals as well and go back to configure signals, extra things will have been added. So you can see there's a acceleration command raw cal in there. There's now more information about the acceleration rates and things. As we scroll down, we'll also see there's lots more about the drives themselves, so a bit more information coming out of the drives that you can also plot. And as we come down even further, you can see there's more position command options, and you can see all of the individual phase voltage and current feedbacks and commands that are in there as well. This is additional information. You don't always need it, which is why it's hidden behind this option. Just trying to prevent you having too many options to choose from. As you can see, it does make the list quite a lot longer. One of the most useful parts of it is this also gives you the encoder sine and cosine. So if you're having issues with an encoder, you can see the raw feedback coming from that encoder, which if we just put it back to hiding the internal signals, we will then see that while those are available still, some of the others are no longer available. Things like a lot of the drive information is now hidden. There you go. That concludes this motion control platform educational video. Thank you for watching. I hope you enjoyed learning about the Automation1 Visualize workspace and data collection configuration.